Hello everyone, I'm Ali Kandemir, Axis CDT 18 student. Today I will talk about natural fiber reinforced epoxy polymers in which discontinuous natural fibers are aligned by using the HiPerDiF method. Before I start, I would like to talk about my project, which is to demonstrate the capability of HiPerDiF for sustainable composite materials. There are two main constituents for composites: fibers used as a reinforcement and polymers as a matrix. The fibers are mainly carbon and glass, and they are used to reinforce polymers such as epoxy. However, they are not renewable, easy to recycle, biodegradable, and they have high environmental impact, and hence they are not sustainable. In my project, I'm focusing into those two constituents, and my objectives are selection of sustainable reinforcement material and sustainable matrix, compatible with the HiPerDiF method, and demonstrate a sustainable route for aligned discontinuous fiber reinforced polymers. And today we will focus on the fiber side and the HiPerDiF method. HiPerDiF method, or high performance discontinuous fiber method, is a water-based short fiber alignment process to form highly aligned fiber preforms or composite prepregs. And it offers sustainable route for manufacturing composites when sustainable constituents are used to produce composites. In the previous study that's published on materials, we investigated some of natural fibers, which are flax, coir, jute, and kinaf, intrinsically, and examined their suitability with the discontinuous fiber composite production methods. We found that flax, coir, and jute fibers are good candidates, and mechanically they are comparable to glass fibers. Also, it was found that they are suitable to be processed with discontinuous fiber composite manufacturing methods. In this study, we used the candidate fibers to produce highly aligned natural fiber epoxy composites. The outputs from previous research, which show the interfacial shear strength of fiber with epoxy matrix, obtained by using microbond test as illustrated in the figure on left, allowed us to calculate the critical fiber length of fibers, which is important to define the mechanical properties of short fiber composites. Thanks to these results, we determined the cut length for this study, and we produced discontinuous natural fiber preforms by using the HiPerDiF method, as seen in the first figure on right. Then the preforms were impregnated with epoxy resin to form prepregs. By using 4 prepregs, we produced these composite specimens, and they were tensile tested. Here you can see the representative stress strength curves and the mechanical properties of highly aligned natural fiber epoxy composites. It's seen that 4 mm jute composites, 6 mm coir composites, and 6 mm flax fiber epoxy composites showed promising overall mechanical performance. However, we found that only 6 mm short flax fibers are the best candidate due to the high stiffness, strength, also due to their current market status, availability, especially for UK market, that hints its potential for sustainability. The study includes these results and also results with polypropylene and PLA polymer composite is recently accepted and published on special issue of materials, which is open access and people who are interested can easily check. In following verse, we will investigate the relationship between flax fiber and sustainable matrices, which can be degradable thermoplastics, bio-based thermosets, or repairable, reformable resins. And these promising resins, which are considered to be sustainable, will be used to manufacture HiPerDiF natural fiber composites. I would like to use this opportunity to thank BCA technical support team, especially in Chorley, for their incredible support during the pandemic. If you have any questions, I will be also presenting these as a poster in the poster session. See you there. Thank you for listening.